presentation, and I'll just move quickly on to the next group. We're a little bit behind, so I'd just like to invite Jade and Jing, Jade from UTS and Jing from Origin Water International. They will be doing a presentation on nutrient recovery using membrane technology. So if during lunch, if people haven't uploaded their presentations, if they could bring it up during lunch.
So good afternoon, everyone. So I'm Jade Jiang. I'm from UTS Research Group, and she's Dr. Jing. She's from Origin Water International. So today we're gonna present the presentation titled Nutrient Recovery Using Membrane Technology. Right, so I'm gonna start with introductions of the collaborative projects between UTS research team and the Origin Water International for the nutrient recovery using membrane technology. Then I'll hand you guys over Dr. Jing and talk about the introduce the Origin Water International. Right, so our first collaborative project titled Fertilizer Recovery from Salt-Saturated Urine, well membrane bioreactor and heat localized solar evaporation. The main research findings include, first of all, the salt-saturated urine can be recovered as a solid fertilizer via this hybrid system. The heat localized solar evaporation can achieve a high vapor flux and solar to vapor conversion efficiency. The system process has a zero energy consumption, small footprint, and low cost advantages. And the generated solid fertilizer has an excellent performance in basal growth. So you guys can see these figures. We did the hydroponic test between for the growth of the basal using both urine-based fertilizer and the commercially available fertilizer, and you can see the growth of the basal with our fertilizer do look better. Then the second collaborative project titled Potential Nutrient Recovery from Salt-Saturated Urine through Hybrid Membrane Bioreactor and Membrane Capacitive Deionization. So in this study, we investigate the complete nutrient recovery and removal and recovery from the actual urine. Use the hybrid MCDI, MCDI system. So the key findings of this research can be concluded as the hybrid MCDI system can effectively removal and recovery nutrient from human urine as a sustainable fertilizer. The it's an energy efficient process for removal and recovery of ammonia and nitrate. Then with a low voltage resulted in lower removal and recovery efficiency in that efficiency of the ions in that hybrid system, and significant improvement and in performance at high voltage absorption and high reverse voltage desorption. The third collaborations between our UTS research team and Origin Water International titled Feasibility Study of Powdered Activated Carbon Membrane Bioreactor for Salt-Saturated Urine Treatment, comparison with MBR. So in this study, we introduced the powdered activated carbon addition to the previous MBR reactors to investigate the performance of the nitrification efficiency, the biomass growth, and also the removal efficiency of 6 targeted micropollutants. So the conclusions of this study were with PAC additions in our previous MBR, we can improve the organic removal efficiency from 88% to 96%. We promoted the rapid biomass growth, and we increased the flock size by 17%, and we can achieve more than 99% of the removal efficiency among all the targeted micropollutant. And also we reduce the membrane falling propensities. The latest collaborative project between UTS research team and Origin Water International was titled a Microbial Community Analysis of a Membrane Bioreactor Incorporated with Biofilm Carriers and Activated Carbon for the nitrification of urine. So the main conclusions from this research project were, first of all, the PAC and biofilm carriers incorporated MBR shows a higher nitrification and lower hydraulic retention time. The microbial diversity and richness reduced by PAC and biofilm carrier addition. And last but not least is the separated urine feeding significantly shifted the microbial community dynamics. All right, so I'll hand you guys over to Dr. Jing.
As I mentioned before, Orange Water actually mainly working on applied membrane technology to water and wastewater treatment and reuse. So we have done many collaboration projects with UTS, with Professor Sean, from microfiltration membrane to RO membrane. So for this project, we can develop the unit for MBR and also for the ultrafiltration for RO pre-treatment or just for membrane technology application. So for this project, we were just working on MBR. So basically this one is a small one, as I mentioned before, it's a really baby one. So the tank actually very small. The whole system is about like it's also small, like the dimensions. We'll see about like 170 high. That's small, and capacity is also small for our system. But during that process, we can modify, and also we can see how this system can work well with a nutrient recovery. So we will find the benefits from this project to our technology, and I'm sure also benefit to the community in the future. That's the design. So from that design, we can see really complicated system. But in MBR system, that's the everything we need to concern for the water level control, and also for the all meters control to connect to the control system. It's okay. That's the real system we actually saw before, and the inside system actually is complicated. It's really like the treatment plant. We just keep everything to the small scale. So I hope everything is working well, and then I hope we can work together for the future projects. Thank you.
So I'll keep it on here. And here's our future collaboration plans. So we are targeted, our KPI is we wanna achieve, publish 3 journal articles together, and present our collaborative work in 4 international conferences, 4 seminars, and 4 scientific talks, and also manage to release 3 tweets or posts through the social medias in our ARC Nice Hub platform. Right. Thank you so much.